Okay, hey folks, welcome. I am Reuven, and we're going to talk about dates and times in Pandas. So first, quick word about myself. This is what I do for a living. I teach Python and Pandas. I go to companies around the world and I teach them all sorts of things about Python and Pandas. I have online courses as well. I have newsletters, including something called Bamboo Weekly, where every week you get new questions in Pandas having to do with current events, the news. Wednesdays I send questions, Thursdays I send answers. If you're lucky, I'm on YouTube, I'm on LinkedIn, all sorts of places. I've published some books, Python workout, Pandas workout with exercises, and you can even go to my booth and sign up to win copies of these books later today. But let's get to our topic, which is, what is time? And basically, time really means two different things. When we use human language, we don't even know it, but we mean two different things. But when we're using a programming language, when we're using Python, when we're using Pandas, we have to break this down. One of those things is a particular moment in time. It's a specific time, maybe when someone was born, when someone dies, when a meeting starts, if the meeting does not start on time, when a flight will arrive, when your book draft is due, although that's what we call an imaginary number. And then we have spans of time, right? How far is it between 2 points in time? So how long someone was alive, how long a meeting lasted, although the answer is too long, how long a flight lasted, right? How long you slaved over your book. No connection to reality. And basically, Python and Pandas handle these two different ideas with two different objects. And so to describe a particular moment in time, we use what's known as a datetime object. And in some systems, we can call these a timestamp. It's the same idea exactly, just different terminology. But if we want to describe a span of time, then we use something known as a timedelta object. And sometimes these are known as intervals. Now, once we understand these two things, then we can start to do date math. So if I have something starting at a particular time and something ending at a particular time, then I have those two timestamps, those two date time values, and the time between them is an interval, is a time delta. And then I can do date calculations. I can say, well, the end date time minus the start date time gives me a time delta. Or I can say the start date time plus the time delta equals the end date time. Or I can say the end date time minus the time delta is the start date time. And this might seem really obvious after you've seen it. But before you've seen it, at least for me, it wasn't obvious how these things work together. And this is really, really useful because our world is full of time and date info. So when was a temperature taken on a particular gauge? When, again, someone was born. When a politician started their term of office. When someone graduated from school, right? When someone got into a taxi. When someone started, when someone ended their workday. Each of these can be measured, and each of these, if we have them in our data set, are things we're going to want to work with and manipulate. So if I want to get datetime information to Pandas, so I can use a binary format like Excel, and that will handle the datetime info just fine because it comes as a datetime. But if you're like many people and you're using CSV, CSV is a textual format, and it needs to be interpreted and then turned into the binary format. And so if I want to read taxi information into CSV, and this is New York City taxi information. You can see here in the picture the computer that is in the back of a taxi in New York. Right back when I was little growing up in New York, there were no such things. There were no advertisements blaring at you. You paid in cash, you got cash back, end of story. Nowadays, you get into a taxi, loud advertisements telling you how amazing things are, but it's actually a computer keeping track of when you got into the taxi, when you left the taxi, how far you went, how much you paid, and also encouraging you to tip, I don't know, 100% or something. And so it keeps track of the starting time, the ending time, how many passengers, actually the computer doesn't do that, the driver does that, how far did people go, how much was the total cost, and so on and so forth. So I can use read CSV to read it in. I set the file name here. This is taxi data from January 2020. I use read CSV. I read in that file name, and I say the only columns I want are when was the person picked up, when was the person dropped off, how many passengers, how far did they go, and what was the total amount. And I can find out what data I got here by saying df.dtypes. Fantastic, except that it's not so fantastic because the date and time information was read in as strings, which are represented here as object. Meaning, Pandas didn't identify it as an integer, didn't identify it as a float, so it's like, I don't know, I'll just treat it as a string. To the naked eye, it looks just fine. But realistically, if you're working with the data, not so much. So what can I do? Well, I can use the pd2datetime function. And if I give it a series of strings that are in a good format, and we'll talk about that in a moment, then I'll get an output of datetime values. And then I can convert a column just by feeding in the original column and assigning back to that. So for example, I can say here, tpep pickup datetime equals to datetime of the original tpep pickup datetime, and the same thing for the drop-off datetime. And if I perform these two assignments, great news, it worked, df.dtypes. Now I ask for it, and we can see each of the columns that have datetimes were indeed treated as datetime 64 with nanosecond accuracy. Fantastic. By the way, here's another bonus of doing that. It's not just that now we can work with them as datetime values. Now they take up way less space because you can see it's a datetime 64. It's 64 bits, 8 bytes. Before, when I had them as strings, they actually took up 977 megabytes, nearly a gigabyte of memory. But putting them in datetime format used 75% less memory, about 250 megabytes worth. So we are gaining functionality and we are saving memory. Big win. Yeah, that's great, but what if some of those dates are not really valid? Well then, by default, we'll get an exception. We'll get a value exception. And it'll say, I don't know what to do with this. Now we can actually change this. We can force it to accept things by saying errors equals, and then by default it's raised, meaning if there's a problem, raise an exception. That's where we'll get our value exception from. But if we say errors equals coerce, that means I don't care if there's a problem, I still want this data to be read in, and then I will get NAT, not a time. It's like the time version of not a number, of nan. And so if I say here, for example, right, pd2datetime of a date column somewhere, errors equals coerce, I'm guaranteed to get that back. I will not get a value exception, but I'll get nat if there is something there. But there's another way to do this. I can just do this directly inside of readcsv. If I say in readcsv, parse dates equals, and then I give a list of columns that contain date information, we'll be just fine. And then we will get our date time columns there. So I just give it a list of columns. I can either name them with the column names, or I can use the numeric indexes. Now, it doesn't offer all the functionality of toDatetime, but it offers an awful lot of it. So for example, we cannot say errors equal something. It assumes that it always has to work. And so for example here, I can now say readcsv of file name, the same use calls as before, but now I say parse dates equals, and we get the same results as before, where now these two columns are in datetime format. Okay, great. Yeah, that's great, except anyone who has ever worked with dates knows that they come in a lot of different formats, some of them totally crazy. So what are we supposed to do there? Well, Pandas is actually pretty smart about how to deal with normal, regular date formats. But some of them are a little ambiguous. For example, if I say 2/3/2024, is that March 2nd? Or is it February 3rd? And it depends on whether you are American or cultured. And basically, the question is, does the day come first? Oh, did I offend anyone? Okay. Anyway, it depends on whether the day comes first or the month comes first. Right, so by default, Pandas assumes actually it's in US format with the month first. But if you say day first equals true, then it will flop those and the interpretation of them. By the way, if you have your dates in year, month, day format, which is standard in Asian countries and also in a lot of log file formats, then it's not going to be an issue whatsoever. Yeah, but what if you have a really odd date format? Well, then you can pass the date format parameter. And you can use this with either toDatetime or readcsv. And it works the same as stirptime and stirftime, the parsing time and formatting of time functions. And everyone remembers all those, right? No one remembers those codes. So friends, you can go to stirftime.org or stirfty.me, and you will be able to get all those codes that you need. And the idea is basically we describe the format we want with percent signs and then letters. So for example, if I want to, I can say, right, and I recently had this in my Bamboo Weekly newsletter, so there was a date time format where it said month, day, year, hour, minute, second, and then it had the AM or PM in there. So I was able to specify with date format how I wanted to read it. I used %m, %d, %y, %i, %m, %s, %p, and it read it just fine. So you can really specify all sorts of wild things if you really need to. Fantastic. Now we have date time columns. We're using less memory. We've theoretically got more functionality. Now what? Well, the good news is that we can now treat these as data just as we would anything else in Pandas. So I can use things like mean and min and max and find that out. We can even use the describe method, which gives us the descriptive statistics of our column or of our data frame. And if I do this, for example, I'm going to say tpep pickup datetime of dot describe, and then I'm going to get the description of the data that's there. So for example, when were people picked up? Now I want to remind you, this data is all from January 2020. That's why the first date there is from the 1st of January 2003, and the last date is from the 2nd of January 2021. This will come as a shock to you, but not all data is reliable and pre-cleaned. You might have to do a tiny bit of work to clean it up and actually believe it. We can do comparisons. Now here's the cool thing. We can actually compare date times using strings. If you just give the date, Pandas assumes it's midnight. So for example, I'm going to find here all the taxi rides that started exactly at midnight. Or I can find it at a particular time, and I can even do less than and greater than. So here I'm finding the taxi rides that took place between midnight on January 1st and midnight on January 2nd. Great. Better yet, if we can compare these values, we can sort these values. So I can say df.sort values, pick up date time, and then I get it from the earliest to the latest time. And sure enough, fantastic. By the way, if you want it from latest to earliest time, you just say ascending equals false, and it works just great. I can even use n largest and n smallest. Find me the 3 rows that were with the lowest times, the earliest times, or find me the 3 rows that are from the latest times. Fantastic. I can also ask interesting questions. I can say, well, what was the mean trip distance on New Year's Day? So I can run this, I can say, well, on New Year's Day, as we saw before, right, give me then just the trip distance column and calculate the mean. And then we find out on New Year's Day, people traveled an average of 3.5 miles. But that's not really where things get interesting. Where things get interesting is where I can dig into the date time values and pull out particular fields. And we do that with the .dt accessor. And if I use .dt, I can pull out, for example, .hour. And that means at which hour of the day. Like it pulls out from that timestamp, from that date time, what hour was it? And I can then find out, okay, these were the hours at which the taxi rides happened. I can pull out a lot of things. I can get the year, the month, the day, the hour, the minute, second. I can get the quarter of the year. I can get just the date part. I can get just the time part. I can even say what is the day of week. I can say, what is it, the year start or year end? The quarter start or the quarter end? The month start, the month end. I can find out, is it a leap year? I can find out how many days there were in a month. I can even get the name of the month or the name of the day. Fantastic. And then I can ask and answer lots of questions. For example, what was the percentage of taxi rides on each day of the week in January 2020? So I can say here, okay, well, I'm going to say, here's the DT day name, and then I'm going to run value counts. And if I run value counts, it tells me how many values there were of that. But if I say normalize equals true, it gives me the percentage. And here we go. Now I found out the percentage of each day of the week of these taxi rides. And we can see, because value counts sorts from greatest to lowest, greatest to least, by default, the most rides were on Friday and the fewest rides were on Sunday. Well, once I've got that, right, then I can just do like a histogram, and I can say, show me for each hour of the day how many rides there were, right? So I'm going to pull out the hour, I'm going to do a histogram, I'm going to make 24 bins because there are 24 hours in the day, And we can see, and this will shock you, there are very few taxi riders at about 4 a.m. and many, many more at about 6 p.m. Okay, well, how long did these rides last? Well, to answer this question, we're going to need a time delta. And we can get that by subtracting the start time from the end time. And then I can assign it to a new column. So I'm going to say df of trip time equals the drop-off time minus the pickup time. And then how long were the rides? I'll find out. And here we go. You can even see this is a time delta column. It says so. That's the dtype. And each one of these values tells me how many days, hours, minutes, and seconds. Actually, that's a bit of a lie, because it turns out that in a time delta, they're only storing 3 things. They're storing the number of days, the number of seconds, and the number of microseconds. However, it is displayed to us as days, hours, minutes, seconds, because, we're human. So I can get these with .dt. I can even invoke the total seconds method, which tells me how many seconds total were in that time delta, and then I can sort them, extract them, run all sorts of things there. So I can then use aggregation methods on time deltas using total seconds, right? I can even do describe. And we can see here that the shortest trip was minus 2 days long, and the longest trip was nearly 6 days long. I know, it sometimes feels like you're in a taxi for 6 days, but to actually be there for 6 days seems a little extreme. I think I actually checked, and that person paid like $2 for the privilege, so, although cheaper than a hotel. Anyway, comparisons, we can do that here. Now I can say, show me where the trip time was greater than 0 days, 1 hour, 0 minutes, 0 seconds. But why would I do that? I can do that, but I can also use just plain old strings. I can say greater than 1 hour, and it will take the number, and it'll take the unit, and it'll do that comparison. So I can do it either as 0 days, 1 hour, or I can say just 1 hour, and either way I get exactly the same mean trip distance for rides that were greater than 1 hour long. And I could use other units too. I can say, for example, show me the mean, or how many rides were longer than 3 days. And it turns out there were 4 of them. Egad. Time zones, everyone's delight. So datetime values can optionally include a time zone if we want. So there's some common scenarios. We can have naive values without a time zone. We can have with a time zone. We can have without a time zone, but we want it to be associated with one. And maybe it has no time zone, but we want it to be in UTC, which is a specific case of the earlier one. So if it includes a time zone, let's just read in this data here from an old server that I have. And the time zone here is specified. So after, right, it's going to be day, month, year, hour, minute, second, and then it says plus 200. That is the time zone. And if I want to, I can then use date format, which I mentioned earlier. I can say %z, that will bring in the time zone. And then, what does my data look like? Almost identical to before. If I say now, show me the 5 top values, I will get those values with the time zone. But here's the thing. The dtype is no longer just datetime 64. It's now datetime 64 with a specific time zone attached. It's no longer naive. Okay, but what if I have naive values and I want to turn it into one with a time zone? I can use tz_localize. And that will then give me back, we can see here, I'm going to give it the America-Chicago time zone, and it will come back, sure enough, with datetime 64. And then it says America/Chicago. We have managed to then take this naive set of values and associate it with one particular time zone. Okay, what if I want to convert from one time zone to another? Meaning, we've already got values in a time zone, and we want to move it to another time zone. Well, guess what? We've got tz_convert. And I can say, and this is perhaps a little crazy to do, I know that these are New York City taxis, but I want to know about them in the Los Angeles time zone. Not recommended, but okay, Pandas will let you do all sorts of crazy, silly things. And so sure enough, after doing that conversion, we now have the values in a dtype where it's datetime 64, but associated with Los Angeles rather than Chicago or New York. Okay, enough about time zones. Let's talk about grouping. So how much, on average, did a taxi ride cost? And the answer is, we can get df total amount dot mean. So far, so good. We see that the average cost is $18.50 more or less. But what if I want to ask a different question? What if I want to ask, what is the mean cost for each hour of the day? Well, we know that for this sort of, I want an answer for each value, I'm going to use group by. But what am I going to group by? I want to group by the hours. But that's inside of the date time, right? It turns out we can actually retrieve dt.hour and use that with a column name and get it. So I can say, for example, df group by and just specify df tpep pickup datetime .dt.hour, and it works just fine. And then I say I only want to check it on total amount. I want to get the mean, and sure enough we get, for each hour of the day, the mean cost of a taxi ride. Of course, we can also plot this. So I'm going to grab, once again with a group by, I'm going to once again do a plot.line, and we're going to find out, again, the same hour at which there were very, very few taxis, there are you have to pay a lot. So maybe it's worth, if you're a taxi driver, getting up a little early to do it at that time. What about pivot tables? Right? A pivot table is basically a 2D group by operation. You need two categorical columns, not just one. One of them will be the categories we use on the index, and the other one will be on the columns. Now, can we use a date time for a pivot table? Of course, because it's just a group by. So for example, I could say, categorical 1 is the day of the week, categorical 2 is the number of passengers, the value is the total amount, and for the mean will be the aggregation function I use. By the way, couldn't I just have done this as a group by with the two columns? The answer is yes, and then I would have ended up with a series with a 2-level multi-index. Watch this, folks. Here is my multi-index with 2 parts, right? And then I pivot it. That's why it's called a pivot table. Ta-da! Anyway, basically it's the same data, just moved around a little bit so we can understand it better. And I say here, pivot table, where the index equals this, the columns equals that, the values are total amount, and then I get this nice table here showing me for each day of the week and for each passenger count, how much did people pay, and it works just fine. We can also group things chronologically. I can say here, for example, right, what if I want to say the earliest time span in my data until the last time span in my data, chop that up into days or weeks or hours or months or whatever it's going to be, and then I want to group by that. Right, so I want the first 24 hours, then the second 24 hours, then the third, and so on and so forth. This is a job for grouper. And grouper, it's a kind of fish if you didn't know. Anyway, and grouper basically says, what column do we want to use, and what granularity do we want to analyze it with? And then we can pass that to group by or pivot table. Now, these granularity offsets are not obvious. You can get them in the Pandas documentation, but it's a little bit hidden. And it's true that you don't only use grouper with datetime, but that's like one of the most common things you're going to want to do. So for example, I want to find the mean taxi fare for each week in my data set. So I'm going to say group by, and then in the group by, instead of specifying a column, I'm going to give it grouper. And I'm going to say I want tpep pickup datetime, frequency equals 1W, meaning 1 week at a time. And I'll grab total amount, and so forth. Now, it's not quite the same as group by. Let's get the difference. Group by means I'm going to take all the values there that exist, and I'm going to use each of them and calculate the aggregation on each of them. By contrast, if I use grouper here, I'm going to get from the earliest time to the latest time. So if I'm getting it for 1W, 1 week, that means in my 1 week of January 2020, I should get 4 values, right? So close, 940 values. Why? Because that stupid value from 2003, that's the earliest. And then it's going to be nan, 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 nan. Oops. Yeah, that was a little violent. Nan, 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 until you get to the end. So it worked, right? As someone said to me many years ago, computers don't do what you want them to do. They do what you tell them to do. We told it to give me this, and so that's what I got. So really what I need to do then is use drop NA, right? I get rid of those NaN values that are not interesting, and then suddenly I have 20 values, still a little more than 1 month, but more reasonable. Can I do a pivot table with grouper? Absolutely. And there are not going to be NaN problems here because of the way it matches up. So once again, I can say pivot table, but now the index is going to be ungrouper. I'm going to say, give me one ME, meaning 1 month end intervals there. So my index, my rows are going to be identified by months. My columns are going to be the passenger count. And here we go. I get that pivot table from it. I can also index with date times, meaning if I take my date time column and move it into the index, there's nothing wrong with that, and we call that a time series. And if I have a time series like this, df equals set index of pickup date time, now I can do all sorts of cool things. So first of all, let's just look at our index for a moment, and we see its date time values. Okay, not a big surprise there. That's what I just wanted to do. What if I want to retrieve rows? Well, first of all, I can just say, give me the full date time. Year, month, day, hour, minute, second. It'll give me all the taxi rides that match that specification. But if I leave off a finer grained part, if I leave off the seconds, it will match any number of seconds for those hours and minutes. If I leave off the minutes, it'll match any of them, and so on and so forth. I can even just give the day, and it'll match any time during that day. So this is a great way for us to retrieve for a particular time. And I would argue it's sometimes easier and faster for us, maybe not for the computer, to set index, grab that way, and then reset the index, than to actually go through all the comparisons inside of our values there. And the coolest thing we can do with a time series is resampling, which is kind of like grouper that we saw before, but without group by. Now you can only resample if your index contains datetime values. So what you do is you specify the frequency, specify the columns, specify the aggregation, and once again you will get NaN values where there's no input data. So I'm going to say, for example, df, resample at the end of each month, 1 month, total amount and mean, meaning give me the average amount paid per month. And sure enough, we're going to find here we have the end of each month. Here we have the amount that was paid on average. Fantastic. Bottom line, Pandas gives you a lot of datetime functionality. We can turn textual data into datetime values. We can extract values. We can create time deltas. We can sort and compare these values. We can handle time zones. We can do grouping. We can do pivot tables. We can retrieve from a time series in a variety of ways, and we can even resample for chronological grouping. I think that date and time functionality is one of the least appreciated and least known parts of Pandas, but one of the most useful. I use it basically every day, and I hope that this gave you some ideas of how to improve your use of it as well. Thanks so much.